In this video, we will look at predefined functions. The two predefined functions that we'll look at is square and square root. Square is a function that can receive an integer or a real value. It will find the square of a number and return the answer as an integer or real. Let's look at some examples. If I find the square of 4, finding the square means multiplying it by itself. So that's 4 times 4. That's going to give me an answer of 16. And the answer 16 will be stored in the variable ans1. And since the parameter 4 is an integer, this variable ans1 should be declared as an integer as well. In the second example, we're squaring a real number. By squaring a real number, the result will be real. Therefore, when declaring this variable, it will be declared of type real. The next function is square root, which is SQRT. And this will receive, it could receive an integer or a real value. It will find the square root, but keep in mind that the return value is always real. So the square root of 9 is 3, but the answer, when the answer is returned, it will be returned as 3.0. And this variable will be declared of type real. The second example, 12.3, the square root will be evaluated and the answer will be stored in the variable ans2, which will also be declared of type real. Before we look at other predefined functions, let's look at the ASCII table. Let's understand what the ASCII table is before we can look at some other predefined string handling functions. Firstly, ASCII, ASCII, it's a coding system. We pronounce it as ASCII, and it stands for the American Standard Code for Information Interchange. It represents 128 characters, and each of these characters are assigned numbers starting from 0 up to 127. For example, the ASCII code for uppercase letter A is 65. So this is the coding, the ASCII code. If we look for capital letter A, which is here, capital letter A, the ASCII code is 65. In the same way, if we look at a lowercase letter A, if we search for that, you'll find it here. And lowercase a, the ASCII code is 97. Then if we look for the number 0, we will find it here, which has an ASCII value of 48. A few other ASCII values you may be familiar with. You'll remember that a tab is #9. That is why we use the character 9, because the tab has the ASCII value 9, and the enter key, which is your carriage return, that has an ASCII value of 13. So effectively, this is an ASCII table. It has all your characters on the keyboard, and for each of those characters, it translates into a decimal value. Also, you should note that if capital letter A starts at 65, then it goes in sequence where capital letter B will be 66 and capital letter C will be 67, etc. Let's try to apply this in some of our examples. So let's look at the predefined function SUCC. This is successor. It is a function that will receive a character, will find the next character in the ASCII table, and return it as a character. For example, if we find the successor of A, we know that the successor of A in the ASCII table that we looked at is B. So SUCC successor will return the next value in the ASCII table. And in this case, A, the successor of A was B. The variable that it is stored in will be declared of type char, or you can declare it of type string as well. What do you think the successor of capital letter Z is? Well, according to the definition, it's the next character in the ASCII table. So let's go and find capital letter Z. Capital letter Z is there. It has the ASCII value 90. So what's the successor? The successor is an opening square bracket. So here we will get an opening square bracket, which will be stored in the variable ch2. The opposite of successor is PRED, predecessor. This will receive a character, find the previous character in the ASCII table, and return the character. So we know that the predecessor of Z, we expect that to be a capital Y. But what is the predecessor of A? Well, let's check it up in the ASCII table. There's capital letter A, and your predecessor is the @ symbol. So this will return the @ symbol. So if we understand the ASCII table, it becomes easier for us to use these predefined string functions. I don't think you need to remember all of the ASCII values. I would suggest some of the key values you should remember is capital A starting at 65, small letter a starting at 97, and a 0, which is at 48. Odd is also a predefined function. It will receive a character. It will find the ASCII value as an integer and return that as that number. For example, odd of A, we know from our previous examples that the ASCII value for capital letter A is 65. So odd will return 65. Capital Z is 90. Odd of Z will give you 90. And a small letter a is 97. So odd of the small letter a will return 97. In the ASCII table, you'll see a distinction is made between capital letters and small letters, each of them having their own ASCII value. These will be stored in variables, and these variables will be declared of type integer. Char is also a predefined function doing the opposite. It will receive a number, and that number will then be converted into the character equivalent and returned. So the value 65, if we take char of 65, we know that is capital letter A. So the value returned is A. 90, we said, was capital letter Z. And 48, if you remember, was the 0. So that will return the number 0. And the number 0 will be returned as a character. So all of these variables will be declared either of type char or of type string. Let's look at an example where we need to change from the number 0 to the letter A, or the number 1 to the letter B, and then the number 2 to the letter C, etc. In this case, seeing that we are changing from numbers into letters, let's get the ASCII value. Using odd of 0, the ASCII value is 48. And then the ordinal value of A, the ASCII value equivalent there is 65. The ASCII value is 65. So if we look at the difference between these two values, 65 minus 48, will give you an answer of 17. So if I have the ordinal value of 0, which is 48, and I add 17 to 48, that will give me 65, which is equivalent to the ordinal value of capital letter A. Similarly, if I have 49, this represented as 0. If I have 49, which represents a 1, and if I add 17 to that, it will give me 66, which represents a B. So you can see a relationship between the ordinal values of your numbers to your letters, and the difference between the two is 17. If we had to try to convert this into Delphi code, let's assume we've got a character variable, and this character variable contains some character, which is unknown. We can then work out, let's create a variable inum, and work out the ordinal value of that character. So that will give us the ASCII value, and I can add 17 to that to then give me the ASCII value of the equivalent letter that's associated with this number. Then we can say the new character will be take that value and use char and convert that into a character. So we take our number, this is our number, which is seen as a character. We then add 17. Well, that number as a character is converted into its ASCII equivalent, which is now in a number form. That number, we add 17 to it, get a new number, which is the new ASCII value for the character that we want. That is stored in the variable inum, and then take inum and convert that into character, which gives us the code A for 0, B for 1, C for 2. This is something that will help you in one of the question papers.